Hello, this is Andrew Grimshaw. In the next of the series of GFFS tutorials, this one on fuse mount. Mounting a fuse file system is extremely simple, so this will be a short tutorial. Today we're going to be doing the usual things. First off, who's this intended for? This tutorial is aimed at end users, campuses, centers, wherever, who want to be able to mount the GFFS into their local Linux file system so that their existing tools can just get to it and operate the way that they're used to. We're going to assume that you have a properly installed GFFS client and that you have an identity. In fact, later we're going to assume that you're logged into that identity. We're going to assume that you have fuse rights, and we'll explain what that means, and that you have the grid command in your search path. Strictly speaking, not needed, but it simplifies things. At the end of this, you should know how to start and stop the fuse driver, how to check if the driver is working, and whether the credentials are valid. You'll also know how to check to see if you have fuse rights. Fuse mounting is really simple. Fuse stands for File System in User Space. It's a loadable kernel module that allows people to write their own file system drivers and have them work in Linux without having to write kernel code. And we use this in the GFFS, like many other people do, to provide access to a new type of resource. And that's what we're going to be doing here. It's really a very simple process. This is actually all you need to know. First, you need to make sure you're logged in, doing a grid who am I, and we'll be doing that. You then create the Unix directory that you want to use as a mount point. If you've previously created it, obviously you don't need to do that. And then you mount it. And the no-hup is a bash or a shell command that says don't terminate this process when you exit the main shell. We're going to run the grid command. We're going to call the fuse command within that with a parameter to mount the local file directory called GFFS, and the ampersand says put it in the background. So once you do that, you can access the Exceed or the GFFS file system via your file system. So here's a little snippet I took out of a session I did a few minutes ago. I did a make dir for GFFS. I did the no-hup I just referred to. I do an ls on GFFS, and there it is. And at that point, you can do all the things in there that you could do with a normal file system. You can access resources regardless of location. You can CD into running jobs. You can ls your data that you've exported, etc. So let's go ahead and jump right into this. I'm on a machine here called UVAX1. Those of you who've seen the tutorial on installing a container are familiar with UVAX1. And in my directory here, I have the installer, I have the Genesis 2 directory that you get after you do an install. I have a directory I call share, which I export out in another tutorial. So what we're going to do is go through some of the things that I talked about a minute ago. The first thing we're going to do is we're going to find out if we're in the fuser group, and that's really easy. You just type fuser mount, and if it says missing mount point argument, that means that we are in the fuser group, and we can run mount fuse devices. It's just we didn't tell it which one to mount. If we'd gotten an error instead that said permission denied, that we don't have permission to execute, then we would know we're not in the fuser group and we need to talk to our system administrator to put us in there. Another way we could determine that is we could do a long listing on bin fuse, and here you can see that in fact this machine is configured so that other has read and execute permission on both fuser and fuse mount. So that's how we can tell that. In terms of deciding whether our credentials are valid, all we need to do is do a grid who am I, and it will tell us who is currently logged onto the grid on this connection. So there I'm logged in. I have a couple of groups that I'm a member of. If there's nothing there except this top client cert up here, then what you can do through Fuse is rather limited. I mean, you can basically only see the files and directories that are visible to everybody. So you want to know how to do that. Okay, so let's go ahead. We're going to clear. We're going to do an mkdir on GFFS to create the mount point. Then we're going to do that no-hup that I just described a minute ago. And I'm going to throw that in the background. At this point, it's in the background and going. And in fact, if we now do an ls on GFFS, what we're going to see is that there's the grid GFFS file system. So we can CD down into that and do the things you would normally expect to do. So we're going to CD down into the GFFS and CG. And then into my home directory. Hit return. So now I'm in my grid home directory, and if I do an ls now, it's going to go talk to all the different devices it needs to talk to. Because I actually have stuff all over the world, in fact, that it's now interacting with to find out what's in this directory. So I have a number of things here, which you've seen if you've seen some of my earlier tutorials. This is actually my desktop machine. It's the container for that. There's a set of BESs that I've created. This is an export I have somewhere. I have lots of things in here. One of the things we're going to go down into is we'll go down into Big Deer with the export. And we can see what I have in here. This machine UVAX, by the way, is in Virginia right now. So I'm going to go up one, and I'm going to go down into the pictures directory. I hit tab. Oh, I got to hit tab. Sorry. I'm going to CD down into pictures and do an ls. Now, this is an example of a fairly typical application that I've seen a lot of time in my days. This particular example, we're going to go into the source directory, into the bin directory. And there's an application that we're calling, it's just the main. This happens to be an application that does something with pictures. And a fairly typical thing people oftentimes do is they have a script that basically takes some parameters like the source and target directories, and then it allows the application to do what they want with that. Okay, so now we're in there, and we see this is a fairly typical script file. What it does is checks to make sure there's the right number of arguments, and then it looks in the first parameter as it treats it as a directory, and it says, well, let's look for all the things called ppm. And for each one of those, let's see whether it exists in the target directory. If it does, we'll skip it, and if it doesn't, we're going to run a program called main on it, and the source will be from the source directory, and the target will go into the target directory. So if we exit, we do an ls again, make sure we know what we're looking at, and we're going to go up, and we'll see that there's two directories up there, one called source data, and one called target data. And in source data, we see a bunch of input files. I'm going to make sure the target data directory is empty. Nope, it's not. I'm going to need to do a remove up in the target data. I'm going to do in rm -f target data star. I should have done the -v option. I like to see things going. Okay, so now when we go up there and we look at target data, it should be empty. Indeed, it is empty. So now what we're going to do is we're going to say script.sh, go source data and into target. Oops, target data. And it's going to whip along and do all these computations. So the point of this exercise isn't what exactly the program does or anything, but that we've taken essentially a completely generic application and shell script, and we're having it operate on the GFFS in the background. So this is going to kind of grind along for a while, do whatever voodoo it's doing to it, and out. So that's all you need to be able to do to fuse mount a file system.